This is an example on integration by substitution. We are trying to find the general antiderivative of the integral of 2x plus 3 times e to the x squared plus 3x plus 13. Now, originally when looking at this, it's difficult to see how we might find the antiderivative of this, and that is why we're going to use a technique called integration by substitution to solve the problem. So the process of integration by substitution begins with choosing a part of the function to substitute for a simpler value u. Often, u will be the nested function of the chain rule. So if you think about it, when we're taking the derivative, and we sometimes use the chain rule to multiply by the derivative of the nested function, u might be that derivative of the nested function. So again, we're starting with this function, and we can see that there is a nested function that is x squared plus 3x plus 13 that is inside the function e to the x. So we're going to choose that term for u. So u equals x squared plus 3x plus 13. And now next, we're going to differentiate u with respect to x. So we find that du dx equals 2x plus 3. That's from the power rule, x squared. You bring the 2 down, multiply, and then subtract 1 from the exponent, so that's 2x. And then 3x is linear, so you just have that constant, plus 3. And now we're going to isolate dx. That's just using a little bit of algebra. So dx equals du over 2x plus 3. And now we have u equal to x squared plus 3x plus 13. And also du over 2x plus 3 equal to dx. And now we're going to make a substitution into our original problem. So we have the integral of 2x plus 3 times e to the u times du over 2x plus 3. And now you can see that we can simply cancel those terms, the 2x plus 3, and we have the integral of e to the u du, and that equals e to the u plus c. So now we're going to plug the expression for u back into the antiderivative, and remember that u equals x squared plus 3x plus 13. So our answer is e to the x squared plus 3x plus 13 plus c.